The definition of probability was given by Pierre Simon Laplace. J.C. Cardan, an Italian physician and mathematician, wrote the first book on probability, named the Book of Games of Chance. Probability has been used extensively in many areas such as biology, economics, genetics, physics, sociology, etc. We used probability in forecast of weather, result of an election, pollution demography, population demography, earthquakes, crop production, etc. Probability. Basic and vocabulary. Problems on coins, cards and dice. Let us discuss some new terms which we use in this chapter. Probability. Random experiment. Sample space. Equally likely event. Mutually exclusive event. Impossible events. Sure events. Exhaustive events. Complementary event. Random experiment. An experiment is said to be a random experiment if its outcome cannot be predicted. That is, the outcome of an experiment does not obey any rule. Sample space. The set of all possible outcomes of an experiment are called a sample space or probability space. Example 1. Tossing a coin is a random experiment. If coin is tossed, either head or tail may be appear. Hence, the sample space S is equals to head or tail. That is, number of events n of S is equals to 2. If tossing two coins, the following are the results. Head head, head tail, tail head, tail tail. Number of events is equals to 4. If tossing 3 coins, my dear children, observe on the screen the result of each coin is tossed is given on the screen. Now from the beginning let us see tail, 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 head, tail, head, head, tail, head, 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 tail, tail, head, tail, head, 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 tail, head, head, head. Total events are 8. 4, 2, 1. What does 4, 2, 1 mean? Observe carefully. Yes, in the first column, 4T is 4H. In second column, 2T is 2H. 2T, 2H. Again, in third column, 1T, 1H. Is arithmetically written to remember very well. Throwing a die is a random experiment. If a die throw once, every face has equal chance to appear 1, 2, 3 or 4 or 5 or 6. Hence, sample space S is equals to 1, 2, 3, 4, 5, 6. Number of events n of S is equals to 6. Event. Any subset E of the sample space is called an event. Example, when a coin is tossed, getting a tail is an event, elementary event. An event having only one outcome is called an elementary event. Example, in tossing two coins, elementary events are head head, head tail, tail head, tail tail. HH, HT, TH, TT. Equally likely events. Two or more events are said to be equally likely if each one of them has an equal chance of occurrence. Example 1. When a coin is tossed, the two possible outcomes, head and tail, are equally likely. 2. When a die is thrown, the six possible outcomes, 1 or 2, 3, 4, 5, 6, are equally likely. Mutually exclusive events. Two or more events are mutually exclusive if the occurrence of each event prevents the every other event. Example, when a coin is tossed, getting a head and getting a tail are mutually exclusive. Probability. The choice of occurrence of an event is called probability. Theoretical probability. The theoretical probability of an event is written as P of E and is defined as P of E is equals to number of outcomes favorable to E by number of possible outcomes of the experiment. This quantification into numerical measure is referred as P of E. Complementary events. Event of an all other outcomes in the sample survey which are not in the favorable events is called complementary event. PE plus PE not is equals to 1 implies PE is equals to 1 minus PE not. Exhaustive events. All the events are exhaustive if their union is the sample space. Example, when a die is thrown, the events of getting an odd number, even number are mutually exhaustive. Geometric probability. P of E is equals to area of the favorable space in the given plane by area of entire space of the given plane. Impossible event. An event which will not occur on any account is called an impossible event. Example, getting 7 when a single die is thrown. Sure event. The sample space of a random experiment is called sure or certain event. Example, when a dice is thrown, the events of getting number less than or equal to 6. The probability of an event E is a number P of E such that 0 less than or equal to P of E less than or equal to 1. Know about cards. This is entire deck of cards. There are 52 cards in the pack of cards. Spade, club, diamond and heart. These are the main 4 symbols you look in any deck of cards, playing cards. Out of 26 black cards, 13 are spade and 13 are clubs. Again, out of another 26 red cards, 13 are hearts and 13 are diamonds. All together they give us 52 in total. Here A, 2, 3, 4, 5, 6, 7, 8, 9, 10, all with all symbols. There are 40 number cards including S. Now you see JQKs of all symbols, 4 symbols. There are 12 face cards in a deck of cards. This is entire club, spade, heart and diamond. Observe, my dear children, on the screen. Spade started from A to K, club A to K, club heart A to K, again diamond A to K. All 13 fours of 52 cards are there. Now give examples of 5 experiments that have equally likely outcomes and 5 more examples that do not have equally likely outcomes. 1. Equally likely events. Getting an even odd number when die is rolled. Getting a tail or head when a coin is tossed. Getting an even or odd number when card is drawn at random. From a pack of cards numbered from 1 to 10. Drawing a green or black ball from a bag containing 8 green balls and 8 black balls. Selecting a boy or girl from a class of 20 boys and 20 girls. Events which are not equally likely. Getting a prime or composite number when a die is thrown. Getting an even or odd number when a card is drawn at random. From a pack of cards numbered from 1 to 5. Getting a number which is multiple of 3 or not multiple of 3 from numbers 1 to 10. D. Getting a number less than 5 or greater than 5. E. Drawing a white ball or green ball from a bag containing 5 green balls and 8 white balls. Number 2. Write a few new pair of events that are complementary. When a die is thrown, getting an even number is complementary to getting an odd number. B. Drawing a red card from a deck of cards is complementary to getting a black card. Next, getting an even number is complementary to getting an odd number from numbers 1 to 8. D. Getting a Sunday is commenting to getting any day other than Sunday in a week. Winning a running race is complementary to losing it. Probability. This entire chapter in your class revolve around about only 2 words. They are one, favorable outcomes. 2, total possible outcomes. Favorable outcomes as FO, total possible outcomes as TO. To remember well, favorable outcomes is nothing but your wish or expecting number in the given problem. 2, total possible outcomes is total number of things or objects in the given problem. My dear children, remember well, Question, PE is equal to 0.05. What is the probability of PE naught or not E? That is complementary of PE. We know that P of E plus PE naught is equals to 1. But PE is given as 0.05 plus PE naught is equals to 1. Or PE naught is equals to 1 minus PE. PE naught is equals to 1 minus 0.05, that is equals to 0.95. It is given that in a group of 3 students, the probability of 2 students not having the same birthday is 0.992. What is the probability that the 2 students have the same birthday? We know that PE plus PE naught equals to 1. PE is equals to 1 minus PE naught. That is PE is equals to 1 minus 0.992 is equal to 0.008. Now another question. A bag contains lemon flavored candies. Please, my dear children, observe the question on the screen. Given data. Bag contains only lemon flavored candies. Now, taking an orange flavored candy is an impossible event, hence the probability is 0. That is 2. Also, taking a lemon flavored candy is a sure event, and hence its probability is 1. Question another question. Rahim takes out all the hearts from the cards. What is the probability of one, picking out an ace from the remaining pack? Number 2, picking out diamonds. Picking out a card that is not a heart. Picking out the ace of an heart. Now, my dear children, observe carefully. Rahim, what he did? He removed all the hearts from the cards. The remaining cards were there. How many cards were there after removing hearts? Given data, total number of cards in the deck is 52. But total number of hearts in the deck is 13. Therefore, when hearts are removed, the remaining cards is equals to 52 minus 13. That is equals to 39. Picking an ace. How many aces will be there in the deck? After removing heart, only 3 aces will be there. Therefore, number of favorable outcomes to ace is 3. But how many cards from we have to pick? The total number of the possible outcomes from the remaining cards is equals to 39. Therefore, probability of event is equals to F4 by TO. Favorable outcomes by total. That is 3 by 39. They will be getting cancelled 1 by 13. Now, second, picking a diamond. Number of possible outcomes are 39. Number of favorable outcomes, again 13. PE is equals 13 by 39 is equals to 1 by 3. Third, picking a card not hurt. Number of outcomes favorable to a card not a hurt is equals to 39. A number of possible outcomes to a card not hurt is equals to 39. Therefore, probability of event is equals to FO by TO, that is 39 by 39, that is equals to 1. It's a sure event. Picking out the ace of hearts. As all hearts are removed, it is an impossible event and hence it is probability 0. A die is rolled once. Find the probability of getting a prime number. Number 2. A number lying between 2 and 6. 3. An odd number. 1. A prime number. Given data. Number of all possible outcomes is 1, 2, 3, 4, 5, 6. This 6. Number of Favorable outcomes are 2, 3, 5. That is equals to 3. Therefore, P is equals to 4 to FO by TO. That is 3 by 6. That is equals to 1 by 2. A number lying between 2 and 6. Number of all possible outcomes is equals to 6. Number of favorable outcomes is 3, 4, 5. That is 3. P is equals to 4 to FO by TO. That is equals to 3 by 6 is equals to 1 by 2. Third, an odd number. Given data. Number of all possible outcomes is 6. 1 to 6. Number of favorable outcomes is equals to 1, 3, 5. That is also 3. P is equals to 4 to FO by TO. That is 3 by 6. That is 1 by 2. Thank you, my dear children.